construction. Hello, everybody. I'm Adam Cole from Passive Buildings Canada. Let me introduce people. So we have from NRCan, Mark Carver, who's been working from the Ottawa side of the Pier project to move this along and bring this to Canada. And then from Ottawa also, we have Daniel DeCare. He's with Ottawa Community Housing, and they have built what is 2 passive houses now from scratch, and now we're going into retrofit to passive house levels, or
we've got one completed in February. We're working on our second one, both of which are like 40,000 and 10,000, 100,000 square feet. So we're high-rise passive houses, and now we're going into the retrofit of low-rise.
Really, really laud that work that you're doing there. And you guys are a leader, and we look to you to help lead us out of the wilderness here. And then Peter, of course, is a longtime PBC member and longtime energy nerd from Alberta, who has worked on the Sundance project, which you saw. And Peter is probably one of the more knowledgeable people in these areas in Canada. He's a real asset to us. So, and welcome to our Energiesprong discussion. This was inspired by trying to get us to go beyond the standard webinar and to start to try to bring some people from around the country together to start thinking about how we could potentially get industrial scale retrofits working here in Canada. So what the idea of doing the videos, I hope you enjoyed them. I hope that was helpful. We've already got 12 questions to go through today. And the way we'd like to handle this is this. If you have additional questions that you'd like to add to these questions once we've gone through these original 12, and we have more time, we're going to be stopping this at 1, and you have more time, and we have more time, then we'll ask those questions, okay? But in order to make this more of a discussion, what I'd like to do is we will address the questions kind of as a group here, and then as we go through each question, once the group, we're going to just take a minute or two to answer whatever it is our thoughts are on this, and then we are going to ask you to raise your hand if you would like to talk and speak to this, discuss this, not necessarily ask more questions, but ask clarifying statements, or potentially, give us some ideas and your thoughts on this. So let me read these first 2 questions, because I'm going to ask Saul to deal with this, I've asked Saul from NYSERDA. So the first 2 questions were about cost compression. The person who asked this question wants to understand the areas where cost compression occurred in the Dutch version of Energiesprong, and wanted to understand the cost breakdown percentages of architecturals versus mechanical electrical in the Dutch versions of Energiesprong. I reached out to Jasper van Munchkoff, who's with Energiesprong in the Netherlands. He was not able to attend with us today and was not able to really get me back that information in a quick enough way. But I reached out to Saul Brown from NYSERDA, who has been working on the 6 retrofit New York projects, which are also Energiesprong coming to North America, but in the New York context. And they have some good data on cost. So Saul, if you don't mind, we're going to unmute you. And if you could take maybe 5 minutes or up to 10 minutes, if you can answer both questions.
So my name is Saul Brown. I'm with NYSERDA's multifamily team, and I'm the project manager for the Retrofit New York program, which, as Adam mentioned, is seeking to introduce Energiesprong style solutions to New York State. Particularly, we're focused on the affordable housing sector to begin with. So most of what I'm going to be talking about is in that context of affordable housing budgets. We are making forays into other sectors as well, but notice steep inclines in the costs for those areas, just given the different construction scales that they're at. So I'll speak to that briefly. In brief, we went through 6 design pilots as part of Retrofit New York, 3 upstate, and New York State is climate zones 4 through 6. So 3 upstate projects in 5 and 6, low-rise typology, 3 New York City projects, climate zone 4, mid-rise typology. And what we found was that at the midterm of the design phase, 6-month process, the incremental cost above the business as usual spends were coming in around roughly $80,000, and is obviously in US dollars per dwelling unit, or assuming around 1,000 square foot dwelling unit, around $80 a square foot. above what owners were spending. We relaxed some of the criteria and saw that the prices quickly came down to about half that, but also with some substitutions along the way. Delving into it further, rather than looking at only in terms of incremental costs, we wanted to understand what the special spends were for just the envelope treatment and just the mechanical system treatment. We found that on average in these 6 pilots, there was about $30,000 per dwelling unit being spent on the envelope, about $20,000 on the mechanicals. We then dove into what business as usual spends are in the affordable housing sector. We analyzed around 40 budgets for conventional renovations over the last 3 years, and we found that about 15,000 was already being spent on envelopes and about 11,000 on mechanical systems. Again, that's per dwelling unit. So we're about halfway there, so to speak. The retrofit solutions are costing about $50,000, and these are all in hard costs. These don't factor in contractor markups or soft costs. But in terms of hard costs, we're looking at about $50,000 per dwelling unit for a net zero energy retrofit at this point. And again, that should be net zero energy ready. We're not factoring in solar or renewables on that. That's just the envelope mechanical treatments. But already on the table are about half that, about $25,000 of what owners are typically spending. Addressing markups, we found the general contractors are generally adding about 15% to those costs. And then the soft costs above that vary greatly from the New York City project, anywhere from about 20 to 100% of those costs, whereas the upstate costs were significantly lower, only about 6% being added to that in soft costs. Leaving the affordable housing sector for a second and talking a bit about our forays into other sectors, we're looking at collaborating with the State University of New York on retrofitting their dormitories. We've been speaking with a number of public housing authorities on their retrofits and renovations for introducing retrofits to, and then public schools as well. And we found that the construction costs that apply to those sectors are significantly higher than what we're looking at in a typical private affordable housing development. So just a word of caution to everyone along those lines, if you're considering other sectors, make sure that the pricing that you're working out, if you're talking about prevailing wage agreements and other cost rises that seem to apply, that's worth considering. In terms of the other area that Adam had asked me to look at or speak to in terms of cost compression, we're finding that there's not currently on the market, at least in the U.S., a viable solution, a field-applied EFIS system or a structural SIPS panel that would be optimized for retrofit on existing buildings. Again, pricing varies pretty significantly in these areas. We're seeing that for panelized systems in our initial pilots, we were looking at about $60 to $80 a square foot installed. That's compared to EFIS that was around $16 to $35 a square foot. And high-end SIPS panels, which we're talking about major structural panels that have thin brick fascia to them, those were way up in the $125 to $175 range. But as we've been working with the industry to help them better understand what we're after, again, we're seeing those costs drop significantly to about half of what we're looking at in terms of the high-end SIPS panels, going down from about $150 to about $75 a square foot. We're also looking at some low-end SIPS panels, so pretty simple stuff, insulated foam with OSB or MGO added to the exterior. Those are falling into around the $12 to $24 square foot range, which would then require field-applied fascia to be applied to those in all likelihood. And as a point of comparison, if we're looking at RC panels out of the Netherlands, who currently supplies Energiesprong, They're probably at around in US dollars, $25 a square foot for a plaster finish, around $32 a square foot for stone. Speaking to mechanical systems for the moment, and this is where I'll finish up, the energy pods that have been explored for a New York State market, the preliminary pricing that's coming in, and again, this is soon to be updated. We just have a pond that we're getting the responses for as of today, actually. So we'll see how those prices come in. But initial pricing that's come back has been about $9,000 to $16,000 per unit for a all-in-one Magic Box style Energiesprong type pod. European manufacturers, when you adjust from the euro to US dollars, you're looking at roughly around the same thing. You're looking at about $18,000 per unit, so roughly in the same range. And when you're talking about centralized systems, there's probably also room to come down. But just sticking with the energy pod figures for a second, if you're talking about a $9,000 to $16,000 per unit cost, that's roughly in range with what owners are currently spending on their mechanical systems, as I mentioned a moment ago, around $11,000 each. So we're, you know, with some significant cost compression, we're probably going to be close to parity with, again, what owners are currently spending. That's factoring in piping and ducting, but not all of the other work, such as, you know, opening walls and stuff like that might be required. So hopefully that's helpful. Glad to answer any questions that anyone might have.
Wonderful. Thank you. And thank you, Saul, so much for doing that. It was kind of last minute, and I appreciate you jumping in like that.
My pleasure.
I believe, Saul, for those folks that are interested, is this cost information available as open source on the Retrofit New York website? Can people out there get a copy of this? And if so, can you point us to where?
No, it's not publicly available yet. I'm sort of giving you a sneak preview of the analysis that we've done. We have Stephen Winter Associates working on assembling a lot of this information. It's also sort of fast and coming as things develop. We hope to publish the 2 Stephen Winter reports about this area relatively soon. They should be finishing up work at the beginning of the year, and then hopefully have those on the website sooner rather than later. Yeah, so the other areas, though, that the HVAC pond that I just mentioned, it's pond NYSERDA pond 3519. Some of the information is included in that in terms of projected price points, projected performance levels that you can consult. Even though the pond closed yesterday, it's still available on NYSERDA's website.
Okay, thank you, Saul. So for those of you who are nuts and bolts dollars type people, there's going to be a pretty good North American breakdown of costs coming from Retrofit New York. And of course, you know, the Canadian context is different from the US, but in terms of cost stacks, percentages, there's probably a lot of similarity. Mark, as far as NRCan goes, are we going to also see release of budgets and cost stacks from NRCan in these 2 peer projects, do you think?
Yeah, well, that's a good question, and that will ultimately be up to the project proponents, Daniel and Peter, my co-panelists here, on what is available. It's interesting. It was really interesting hearing Saul discuss the breakdown of costs. I think, you know, one of the big distinctions that I'd make between the Retrofit New York experience and so far the Canadian experience is that the projects that we're working on so far in Canada are limited to low rise. And so we have building typologies that tend to have a lot more surface area. So I think the balance between the envelope side and perhaps the mechanical side will be a little bit different to reflect that. But I think it's really interesting, and I think that compared to the costs that Saul, you were reporting, I think we're on par, or actually the panelized approaches that we've developed and are now starting to roll out are going to be really competitive, frankly, with some of those solutions. which is good to hear. And perhaps Peter has some more. He's furthest along on this. I don't know, Peter, if you're in a position to share any of your kind of cost observations.
So our cost information will be available. We're still working on it. We've done a pilot on 2 units. It cost us about $85,000 per unit on essentially a duplex of about 1,000 square feet each. And we were surprised to see how little of the cost is actually the panels. The on-site work, getting the building ready, dealing with conditions around the building, maintaining safety, all that kind of stuff turned out to be a way bigger chunk of the cost than we thought. The panels really are less than 15% for the wall panels. You know, we're looking at the Dutch experience where they've seen this dramatic fall in the costs and saying, okay, looking at what we actually spent and what we're going to spend on the pilot, where are we going to find those kinds of efficiencies? And it's not super hopeful. A lot of it is going to have to come from developing incredibly efficient on-site procedures where you repeat what you're doing and get really good at it. Have really, I kind of imagine these sort of Japanese Kaizen type procedure, except on a messy site, and you know, that we need to develop these kind of samurai renovators that are completely laser focused and are not going to get sidetracked by somebody worrying about their petunias and stuff like that. I really, and you know, I'm a little facetious, but I think seriously that's where the efficiencies are going to be had, and I think we're starting leaner than the Dutch did probably. We're on a bit of a shoestring budget, and I don't think we're going to have as far to fall.
Well, Peter, if I may, I believe that 85,000 is in Canadian dollars. When you take those Canadian dollars and translate them to US dollars, you know, you're down in the 60-some thousand range. And if you translate it to euros, you're in the 50. So I'd say, you know, right now your projects are actually quite competitive with where the state of the industry is now in both the Netherlands and in New York. Daniel, what are you finding in terms of cost?
Yeah, well, so I was going to say that we're doing our procurement right now, so we're confirming our anticipated numbers, and they are lining up pretty much kind of like what you're describing. We are planning on adding solar panels to our roof, like we are going for the full net zero on our 4 blocks of townhomes. So there is going to be definitely an added cost to that, like that's going to take things out. The one thing we have observed is, for example, the electrical upgrade, which was not an anticipated cost on our side, right? So the things that we knew, like we knew about mechanical, we knew about building envelope, we knew about the solar panels, we were able to model those out and get a pretty good understanding of what was needed there. But when we went down the path of, in order to be able to we're reducing the energy by so much, but we're still going to need to electrify a great deal of loads, and this 100 amp panel can't take it. We need to bring it up to a 200 amp panel, and the transformer that's feeding these 4 units also can't take it. So now we have to work with our local distribution company in order to upgrade that. So those are actually the costs that you say, this is a building envelope retrofit project, but it's going to have an impact on the electrical loads and on the electrical infrastructure for our local distribution company. That's actually the parts that we're having a little bit more trouble navigating, and that are like, you don't necessarily find this out until you make that submission to your local distribution company. So those are where that's where the slope might get slipperier.
Yeah,
and
I believe. I'm sorry. Go ahead, Peter.
We're having exactly the same problem. We have 60 amp service to each of these units, and we need roughly 125. We've got about a 2.5 acre site, and we're finding we have to redo the entire electrical service to the site. Wow. And our solution is to bring in one big 3-phase transformer and essentially set up our own little utility where we will take over the metering. And right now, the co-op members are paying about $25 a month just to have a meter for electricity, and about $650 a year, so over $50 a month for gas. So getting rid of those 2 meters and replacing it with our own system will pretty much pay for the roughly $450,000 it's going to take us to upgrade the electrical system. But it's a hell of a job. Like we're having to make this up from scratch basically, and work with electrical inspectors and utility, and it's not going to be beautiful. We have some physical installation we have to make that we're struggling with a bit. So it's a major component, and I think that this will be fairly common. I mean, we got 2 out of 2 here. We need to make that part of the solution handbook.
Yeah, and I believe that Retrofit New York, at least one of the projects had a similar problem, if not 2 of the projects. Saul, can you tell us in New York, in the 6 retrofit projects, how many of those ran into similar issues?
Yeah, I'm not aware of any issues with the utilities that came up. I think the one that I was most intimately involved with in Troy, New York, they were actually seeing some savings on the metering. So I think they had about a $6,000 deduct as they switched over to all electric. So that's unfortunately my familiarity with it. We have not seen this as a major obstacle, though, at least at this point. Though we're talking about New York State in particular being already solar heavy and having a lot of infiltration in that market. So I think there were probably fewer surprises as we're going to on-site renewables.
Okay, all right, great. I thought the Bright Power project had insufficient electric service, but that neither here nor there. So,
yeah, since they have worked that out, I'm not sure how, though. If it's a significant point, you guys can email me. I'll certainly be glad to get you back the info on that.
Thank you, Saul. Okay, well, before we move on to where this is going a little slower than I thought, so we more than likely will not get through all these questions, so we will deal with that at the end. But before we go on to the next section, which is financing, is there anybody who's on the webinar or on the discussion who would like to speak now, to raise their hand?
Yeah, I have some people up here. So the first question was from Dave Luxton. Do these cost estimates for the energy pods include solar inverters and the systems? That was his question. I will unmute him now. I got to find out where he is.
No, we got the question. I only wanted I was really looking for folks to raise their hands if they wanted to add to the discussion.
There was an addition of the next one was it's Alex DeGagnon saying that there'll be dehumidification and cooling that will add to the costs. Not sure if he wants to speak to that.
Well, let's talk to Saul about his energy pond on your, because I believe that's what they're talking about, that 9 to 16. Saul, is in your in the energy pods in Europe, of course, they have the inverters. Are you speccing that in your pond?
Yeah, we're requiring the inverters and cooling and dehumidification. Not all of the European versions have either of those functionalities, though a couple of the companies that are specced, or one of the options in our pond is to not only develop things locally, but also to bring materials over from overseas. Some of the overseas manufacturers that are given as examples are indeed including cooling at this point.
Okay, well, I would like to take a vote on where we go next, because we're not going to get through all these questions. We have financing, nuts and bolts implementation, and translation to Canadian market. So if you would like to go financing next, raise your hand.
Yeah, no, it looks like 2 people want that one.
Okay, how about nuts and bolts implementation? How many folks would like to discuss that?
That's got quite a few people. That looks like the winner. Just I don't
That's
even have to do the math. That's the winner chicken dinner. All right.
All right, wonderful. So I'm gonna let Mark and Peter kind of take over here. And why don't we start with number 1, the vapor barrier question, Mark? I'll read the question for you. Vapor barriers. I assume that this is the question verbatim. Vapor barriers. I assume that the old poly vapor barrier is left untouched, but assumed to be very leaky, and a new open vapor barrier is applied over the existing exterior surface. What product are you using, and is it spray applied?
Okay, yeah, great question. I think to start off, it's important to acknowledge that every project will be unique and different, and we're going to encounter different existing conditions. And to whatever degree we can streamline a process for identifying the different materials that are in the assembly, assessing their material properties and their condition, and then determining if there are any existing moisture problems. So that's step one in one of these. But I think as we consider our moisture management strategy and in this type of project, it's important to kind of step back and think about what are the real issues and what are the first principles. In terms of vapor retarders, of course, in Canada, those tend to need to be on the inside. So if we're doing a retrofit almost entirely or exclusively from the outside, it's difficult to place them in the right spot in the assembly. And there often will be some sort of material, whether it was ever intended as a vapor retarder or not, that's acting as that in the existing assembly. But I think it's really important to highlight or emphasize that air leakage is the bigger concern from a moisture management perspective, because we can get so much more wetting from air leakage than we can from vapor diffusion. So we need a continuous air barrier system that we need to be able to draw that continuous line. And I know I'm talking to Passive Buildings Canada, and so none of this will be news, but it's, I think, important to consider it, because in retrofit, it can be really challenging. For both the panel types that are being used in these projects, they're both using an exterior air barrier membrane on the actual panel. And of course, there has to be details at panel joints and at interfaces with penetrations and windows. But yeah, both panel types are using an exterior air barrier membrane. It doesn't necessarily need to be on the exterior, but one of the real advantages of that is that it means we can get at the air barrier. So we can make those connections at panel joints. And if you imagine a scenario where we have to do a window retrofit 30 years down the road, we can get at the air barrier, we can tie into it. So that's important. You asked about specifics. I don't want to get into naming products necessarily, but we're both using, and Peter might be able to elaborate on the product he's using, but we're using a fully adhered permeable membrane that could be fluid applied though, and it could be a sheet good. There are a number of different vapor open air barrier products that I think would be perfectly suited for this application.
So we tested our test building at a air leakage rate of 6 and 7 respectively for the 2 units, air change an hour. And they have a 4 mil 1970s applied vapor barrier, which wasn't taken very seriously. And our strategy is to seal it on the outside with a vapor open water resistant barrier from Casella Dorkin. It's mechanically fastened. It's not self-stick. We wanted the flaps to be loose and easy to seal to each other, because we're relying on laps in the membrane to seal the panels together. And it was fairly successful in the pilot. We hit 0.7 air changes an hour. And we think that as we do more of these, we'll get better. We're relying on some vapor openness in the air sealing, and we've also installed a bunch of moisture sensors so that we can actually measure the what's going on at the points that we consider to be the riskiest. So we should be starting to get data now. We're going through the heating season on, the first heating season on the pilot.
Excellent. Oh, we look forward to that, Peter. Number 2, for the foam SIP option, is a drainage cavity incorporated? If not, how is drying to the outside of the wall of the existing wall allowed for?
So as I mentioned, we're using in the SIP-based panel, a pure panel approach, and the one that's being used in Dan's project, the OCH project, we're using a vapor permeable exterior air barrier. And the cladding is installed over a ventilated rain screen to give us a drainage plane and that's basically designed to help eliminate hydrostatic pressure and to eliminate or to reduce the chance of wetting from the outside. But I think this question is also about drying and helping to enhance drying potential from the inside, from any wetting in the inside. So we are using this vapor permeable membrane, but of course we also have almost 8 inches of expanded polystyrene. So the permeance of that's going to be relatively low. And so it will allow drying, but it's going to be quite slow. And we were interested in that because we're not going to necessarily have control. We are adding balanced mechanical ventilation in these units, and that's going to be really important in order to try to maintain occupant loads and keep humidity down. But to add a little bit of a safety factor, we're really interested in trying to use this idea of the squishy layer that you may remember from the presentation. And essentially, that's the interface between a new SIP panel that'll sit outboard of the existing wall and the existing assembly. And that interface is a couple inches thick, and it'll be insulated by some sort of fibrous insulation. That will be very vapor open, and the idea being that is a cavity essentially that extends right from the foundation all the way into the attic. And so we're interested to see if that will help enhance drying potential, and we can use that as sort of a diffusion event. And that's been used, that's been an approach that's been successfully applied to a variety of projects over the years. So just like Peter, we're going to be monitoring the OCH project and seeing how that squishy layer may help enhance drying potential.
Okay, do we have any additional questions? And if not, do we have any raised hands?
I have a couple of things here that I want to take care of before we go. So Peter Darlington has said that he likes to use the liquid applied air barriers, and he likes the cost at $250 a square foot, done by painters, variable perm ratings, highly inspectable. Actually, from my point of view, as a person who does my own work, I kind of go that way too, but I found that other contractors are totally with different views. So I thought I'd bring that out as a concept for this discussion. And then I want to catch up on one that was from before. I sent a question from Dave Smits directly to Mark in regards to what causes the need for larger utilities that we discussed earlier. And those are the only 2 questions that I have right now.
Daniel, you want to address the why switching to all electric does that?
Yeah, well, so right now, I mean, we've got natural gas furnaces, natural gas domestic hot water tanks. So the bulk of the electricity the bulk of the energy that's being used is actually coming from natural gas. The electrical service is only giving us plug load, essentially, right? So we've got a 25 kVA transformer that's feeding 6 units right now, and it's just fine, and a 100 amp service that's perfectly happy. Now we're talking about adding essentially 2 different a heat pump for our domestic hot water, as well as a heat pump for our space conditioning, and I mean some fans along for our ERV. But essentially, the loads that we're talking about for that is going to need to increase our service. We're also looking at adding the solar. Strangely enough, adding solar, which reduces, like, by the generation will essentially be exported out, but depending on how your local distribution company looks at generation, sometimes they want to add that load onto, because I can appreciate in some conditions that's how you have to look at it. So from the electrical services side of things, you're actually looking at adding all of these extremely high demand side, although the energy that we're going to be drawing from them is going to be smaller overall from an equivalent kilowatt hour than before, especially with the generation. All of these factors make it so that in order to install them, you're going to need a larger service, and in some cases, larger transformers feeding them.
Yeah, thank you, Daniel. That was a good explanation. We'll move on to the third question under nuts and bolts. The existing conditions measurement. I think this is a big question mark. Peter said they were looking at using photogrammetry to gather the existing conditions measurements. Is laser scanning still too expensive as the technology appears fully developed and very high accuracy? I know that Mark and Peter, you guys, and Dan, you guys have been working on this, so have at it.
So we played with photogrammetry. We haven't given up on it. We've got a grad student who is confident that he can actually automate photogrammetry more, and we'll wait and see. But we couldn't wait any longer, and we did do a laser scan with a non-survey grade Leica scanner, a BLK 360. And have gotten pretty good results with that, combining it with a SketchUp and actually a program called Undet, made in Lithuania, that is very good at extracting geometry out of a point cloud and has good control, very smooth, and exports to both SketchUp and Revit. And one other program. And so we're pretty excited about that. We've got that down to the tolerance that we need, and are ready to scan a whole half of the rest of the co-op fairly shortly.
Okay, and are you going to be using the photogrammetry? I'm not clear.
We're not using it for now. We're still working with the grad student, trying to help him develop a series of routines that would do this. It's a much less expensive version, and basically it's a good quality 35 millimeter camera with a really good wide angle lens, and as opposed to anywhere from $20,000 to $150,000 scanner with a whole bunch of expensive software that and annual licenses and that kind of thing.
Peter, may I ask one other question? How are you doing your measurements now if the photogrammetry is not ready?
Oh, well, the pilot we did with a tape measure, and on the we're just preparing panel drawings for our next building, the one we did the scan with the Leica on, and we took many tape measurements before we found. Before we got agreement between the tape measurements and the scan, and it turned out that most of the measurement errors were in the tape measurements. That although there are some built-in errors in the scanning process, the errors are limited to the precision of the program. It's really hard to screw up when you can see it right there on your screen in a nice warm office, as opposed to up on a ladder with a tape measure and you know, hoping the wind doesn't blow you off and stuff like that. As long as you can get the point cloud into the small enough range that there's no question that LiDAR is a good way to go.
Dan and Mark, what have you guys found?
Yeah, this is a great topic, and I think we could have a whole webinar dedicated to this subject, and maybe we should.
Maybe.
But I think our experiences so far have been very similar to what Peter had found. From a research perspective, we're still very interested in photogrammetry because it promises to be even more accessible especially for smaller players, because the capital costs to get into it are really promising. I mean, we're talking less than $5,000 Canadian, perhaps for a good SLR and a prime lens and the software. But I think the approach that we've had the best luck with so far, and on the OCH project, on Dan's project, we, in the sort of first phase of it, which is sort of the research phase, we had the ability to take their building, the OCH building, and measure it. We did a number of hand measurements. We used photogrammetry, which we had pretty good results with, actually, with the photogrammetry, except when we didn't. Generally speaking, I'd say we got about 85 or 90% of the measurements we needed within the acceptable tolerance. The problem is when you start to get into a more complicated site and you have more obstructions, like Peter's site, he's frankly got a more complicated architecturally, it's a more complicated project. There are more obstructions, there's more landscaping. And if you can't get the right perspectives for photogrammetry to work, then you're out of luck. That technology is developing rapidly and costs are coming down and resolution and accuracy are going up. So I think that's a really interesting space to watch. And I think in 5 to 10 years, it might be a completely different story. But in terms of this application right now, laser scanning and land-based laser scanning is probably the way to go. There are more and more providers, and the cost of scanners are coming down. Although they're still prohibitive, I think for a smaller player. One of the things I think that we found, and we've been working with a consultant, Jeff Armstrong, from the inception of our project, and he's been responsible for the panel design for the OCH project. And one of the things I think he would suggest that's critical is that we think that whoever's actually building these panels needs to be responsible for the measurement. And the reason there is that if it's being handled by a third party, there are interpretations that need to be made of that raw data, and even discerning, okay, well, is it, am I measuring to a brick return, or is that actually a little piece of flashing that's showing up in a point cloud, or what am I actually, what are the points that are really of consequence here? And so to whatever degree we can kind of again come up with a process where you're working with unadulterated data, the raw data, and if we can be designing panels directly on a point cloud and eliminating any intermediate step of drawing existing building elevations and then designing panels over those, will help us to ensure that we're not introducing additional human error, and also, frankly, eliminating an expensive sort of mid-process step.
Yeah. That's just as a side, Mark. The RC Panels does that. When talking to when we were visiting with the owner of RC Panels, they said they wouldn't try. They want the responsibility. They want to do their own measurements. They wouldn't trust, even if they were handed them, they still go do them themselves, which is smart because who wants to remanufacture? So yeah, I think you're going down the right road. Did I cut you off, Mark, or did you have more to say?
No, that's it, and I think that's all I would say on this. We are working as part of our project on a building capture guide for doing this, where we're going to summarize our results of what we found with photogrammetry and with laser scanning, and provide a bit of a step-by-step process, including sort of target resolutions and things. So that's an output from our project that you can expect next year, 2020.
Well, actually, I was going to ask. I was just about to thank the panelists and ask them if they would be willing. I want to poll the group and see if the group. We've got another 7 questions. There may be additional ones that come up, and I'm wondering if it's worth potentially coming back in 4 to 6 weeks with another one of these sessions. So the first question I would have, panelists, if we can find a time, we won't do it now. Would all 3 of you other guys be willing to do this again in 4 to 6 weeks for another hour?
I definitely would. Yeah.
You would. Okay.
Yeah, I'm learning stuff. So.
Okay.
That's actually, like, we are treading uncharted territory right now, and I think the more we talk about this, the only thing that can come out of it is a better product in the end.
And lots of people coming in with questions now. They've just sort of, yes, please.
Okay. Well, let's do this. I want to stick to the hour format. We've got 5 minutes left, and I just want to wrap it up here. What I want to do first is to thank Mark, Dan, and Peter for all their help. And this process was a long birthing process because we had to go through all their schedules and what they were doing, and it took us a while to get it, but I'm very happy that it seems to be something that people are interested in by the number of people that replied. And I ask all those attending, if you have questions, please send us these questions. Send them to PBC, just like the other. We'll send out a call for more questions. We will, as the presenters, will get together. We will come up with a date in 4 to 6 weeks that works for everybody, and then send that out with requests for more questions, and we'll just continue this discussion. So with that, I want to thank all the panelists. I want to thank Terrell. Terrell, you are an amazing president and an amazing techie queen. I can't believe you handled that tech so well. It was amazing. That was great. And I thank everybody who has attended this in helping me. Saul, I want to especially thank you for jumping in and helping us through those cost numbers. So with that, I'm going to say so long, and hopefully see everybody next month.
Thanks.
Thank you.
Okay, thank you.
Bye.